All right, so in the last video, we graphed our basic tangent of x and cotangent of x functions, and we came up with these facts about tangent and cotangent. Now we're going to go through the process of actually graphing some more complicated tangent and cotangent functions. Okay, so if we're going to graph tangent or cotangent by hand, we first find the vertical stretch factor, a, which is no longer called an amplitude because these are no longer wave functions. They don't look like waves, and so it's just called a vertical stretch factor again. And when we talk about the a value, we're talking about, for tangent, it'd be a tangent of b times x minus c. For cotangent, it's y equals a cotangent of b times x minus c. And that's what the b here and the c here are all about, the a, b, and c. So the vertical stretch factor is still the absolute value of a. The period, instead of being 2 pi over b, is now pi over b, because the period of a tangent or cotangent function is half the amount. Because when you do the ratio of them, we can get through all the values in less time. Phase shift is still the same. It's c. And because the minus is built in, if c is positive, we're actually to the right. And if c is negative, we're shifting to the left. So then, once you know those three things, we're going to try to find our vertical asymptotes. Now we know that for tangent, that normally happens at negative pi over 2. And for cotangent, that normally happens at 0. And we can use that information to find our vertical asymptotes. And we'll go through that process together. And then once you know where one vertical asymptote is, you can take the period and add it to the previous vertical asymptote, and that'll give you a second vertical asymptote. And then we would take that, basically that interval between the two vertical asymptotes, and we're going to divide it into 4 equal parts, just like we did with sine and cosine, because we have 5 key locations. The 2 vertical asymptotes are part of that, and then we have our 3 key points, which is for tangent would be -1, 0, and 1, and for cotangent it's 1, 0, -1. And so this is very similar to what we did with sine and cosine. Finding the scale is also going to be important. And our first stab at finding the scale is going to be just taking that step 3, whatever we got for the distance between our key points. We're going to take that and see if it works with our phase shift. If it doesn't work with our phase shift, then we would adjust from there. So we're going to start by graphing 3 tangent of 2 times x minus 4 by hand. So the first thing I want to do is I want to talk about the amplitude. So the amplitude here is 3, but it's not called an amplitude anymore. So we're just going to call that our vertical stretch factor. Okay, so our vertical stretch factor is 3. Our period is pi over b, so it's pi over 2, which, there it is, my period is pi over 2. So our period has been cut in half, which makes sense because we have a 2 here, not a 1/2. So our period, which was normally pi, is now half the size, it's pi over 2. And our phase shift is pi over 4 to the right. Okay, now because there is both a period change and a phase shift, we have to be very careful about what we assume about where the vertical asymptotes are. So because the vertical asymptote would normally be at negative pi over 2 or at positive pi over 2 for tangent, the period has shrunken. So it's now pi over 2 instead of pi. So the distance between those vertical asymptotes is smaller. That distance is smaller. And we're moving to the right a little bit. And so I can't just say that the negative pi over 2 has been moved pi over 4 to the right and is now at negative pi over 4, because not only has my graph shifted to the right, but it's also shrunken its period. And so the best way to find the first vertical asymptote is actually to take what's inside tangent. So this is what's inside our tangent function. And normally we would find a vertical asymptote at negative pi over 2 or at pi over 2. So I'm just going to set this equal to negative pi over 2. Because I know that if the overall value inside of tangent is negative pi over 2 or pi over 2, I'm going to get an undefined value out of my function. And so I'm going to now divide both sides by 2. So that gives me x minus pi over 4 equals negative pi over 4. And then if I add pi over 4 to both sides, I get that x equals 0. So this is where my first vertical asymptote is. And I know that the next vertical asymptote is going to be 1 period away. So the next one's going to be pi over 2 away from that, which in this case, since we're at 0, is pi over 2. And so it turns out that one of my vertical asymptotes is actually the same value as it would have been all along. And I could have potentially set what's inside tangent equal to pi over 2, and when I do that, I get x minus pi over 4 equals pi over 4, and then when I add pi over 4, I get x equals pi over 2. And you can see this is another way I could have found that second vertical asymptote if I wanted to. All right. The distance between them is pi over 2, which makes sense because that's the period. We're going to take that distance between them, which is the period, and divide it into 4 equal parts. So pi over 2 divided by 4 is pi over 8. So that's the distance between my key points. That pi over 8. And if I look at the phase shift is in pi over 4. It's pi divided by 4, which 4 goes into pi over 8 very nicely. And so if I use pi over 8, 2 pi over 8 is actually pi over 4. So if I use pi over 8 as my scale, this is going to work. So I'm also going to use this as my scale, but I can't assume that right away. I have to first check it against my phase shift. Okay, so I have what looks like all the information I need. So now I'm going to go over to my graph and start graphing this. I know that I want my first vertical asymptote to be at 0, my second one to be at pi over 2. I know that I want to start, the phase shift doesn't even matter because once I have my vertical asymptotes, I've set it up in such a way that I'm just going to go, because this is tangent, I'm going to go negative 1, 0, 1 right down the line, except instead of being negative 1, 0, and 1, it's going to be negative 3, 0, and 3 because of the vertical stretch factor. Okay, and this is going to be the scale that I use, pi over 8. So let's just go over to the graph and make this happen. Okay, so I'm going to make the scale pi over 8, and just because this graph is so wide, I am going to go every other space just so that I have a little bit more room to write. But if you just want every box being pi over 8, that would be fine too. So pi over 8 is my first distance. 2 pi over 8 is pi over 4. 3 pi over 8 is 3 pi over 8. 4 pi over 8 is pi over 2. 5 pi over 8 is 5 pi over 8. 6 pi over 8 is 3 pi over 4. 7 pi over 8 is 7 pi over 8. And then 8 pi over 8 gives me pi. And I can just do these in the negative direction as well. And I am counting up the same way I just did in my head so I don't mess it all up like I did last time. All right. Now, since my vertical stretch factor is 3 here, I'm actually going to label this 3 and this -3. I don't need to label the whole vertical axis, but if I did, that would make this 6 and 9, and this would be -6 and -9. Remember, if this box here is worth 3, then all of the boxes are worth 3 as we go. All right, so we know that our first vertical asymptote is at x equals 0. So I'm going to draw that in. That's my first vertical asymptote. My second one is at pi over 2. And since this thing is symmetric, that means every pi over 2 is going to, it's a pattern, it's cyclic, not symmetric, it's cyclic. I can just go ahead and draw a vertical asymptote every pi over 2 away from each other. So we can actually fit 4 complete cycles of tangent in here, my graph. And again, when we think about the graph, let's just label what the function was. It's 3 tangent of 2 times x minus pi over 4. Okay. Now, when we did sine and cosine, we came up with the scale, and then we still started pi over 4 to the right of where we normally would. But we already figured out where the vertical asymptotes are, so I don't need to start at any particular location, just in between 2 of these vertical asymptotes, and I'm going to go -3, 0, 3. -3, 0, 3. -3, 0, 3. -3, 0, 3. So in between any of these, and I picked my scale so that the distance between my key points would be the points that I labeled along the x-axis. And so that makes graphing this actually much more simple. And I'm just filling in my graph. Now, the directions for most of the problems that I give you will say, like, graph it over a 2-period interval or 1 period. Depending on how you make the scale, just fill your graph as much as you can. Okay, so I filled the entire graph here, and there's my tangent function.